Do you know what that sound is? Yeah, you're right. That's breathing. It's also called respiration. We humans respire by breathing in air, which contains oxygen, and breathing out carbon dioxide. It's this exchange of beneficial to waste molecules that all cells do. Not all living things breathe, because not all living things have lungs. All living things require some molecules and they respire some molecules. That is to say, they release them as waste into the environment. Not all cells respire carbon dioxide, but many of them do. And so, if we want to know how many cells are living in an environment, one of the things that we can look at is the level of carbon dioxide that is released in that environment, because it should be related to how many cells are living and active there. How many cells are taking in beneficial molecules and releasing waste molecules, in this case, as carbon dioxide. So when we in the Schmidt lab want to find out what effect a organic treatment will have on soil conditions in agricultural lands, one of the things that we can do is measure how much CO2 is released from soil that has had different organic treatments. And we do this by measuring carbon dioxide released indirectly through titration. So what we do is we put a sample of soil that has had a treatment on it. And we put those samples within a sealed container for 24 hours. And in that container will also be present a small amount of chemical that will react with carbon dioxide and trap it in solution. In this case, we're going to put in sodium hydroxide, and that will react with carbon dioxide and make a new chemical formula, sodium carbonate or sodium bicarbonate, present within water. So then, after 24 hours, we'll take that new solution where all the carbon dioxide that was released as gas has been trapped within this solution, and we can use acid-base reactions to determine how much carbon dioxide was trapped there. There'll be an intermediate chemical reaction to precipitate out some of the material and leave the solution more or less basic, depending on how much carbon dioxide was initially trapped in the solution. And when I say basic, I don't mean that it is ordinary. I mean, on the pH scale, it is higher than 7. It has a pH that is basic. So if you remember from your chemistry, there's acidic, have a pH less than 7, and basic have a pH higher than 7. 7 is neutral. So within our solution, if there was no carbon dioxide trapped 24 hours, then no sodium carbonate will have been produced. Then all of the molecules will be present in the basic solution. And we know that we will need the exact same molecules of acid as we had present in our initial solution of sodium hydroxide. So in this case, we had 5 mils of a 1 molar solution, which we put in with the soil. If there was no carbon released, it was 100% conserved, then we will need 5 mils of 1 molar concentration acid to neutralize that basic solution. And any less than that, and we know that some of the sodium hydroxide was transformed to do a titration, we want to very slowly measure out how much acid is required, and we want to be very exact. So we will put in perhaps 1 drop of acid at a time to try and measure small volumetric differences in the amount of acid required to neutralize our solutions. So this is a process called titration. We use this very basic chemical approach, acid-base titrations, to measure biological activity in soil. And that's what we've been up to in the last few weeks here at the Schmidt Lab.